So let's start our lecture right now. Okay. Can everyone hear my voice? If you can hear my voice, try to say yes in the chat box. Okay, cool. So let me open my pen. By the way, today the lecture maybe we can end slightly earlier because the content actually not much. There is just a little thing I need you let to know. So right now it's already week 11, so I believe our class also almost ended. And we still have about, let's see, a few classes we need to do for the replacement class. Okay, 2 hour plus 1 hour. So I will try to make the replacement class maybe in the last 2 weeks. Then we will use the revision class to we'll use we'll use the replacement class to do some, let's say, passive question. Let's familiar with the passive question, then we try to do it in the class. Okay, this is what we plan for. So 1 hour is for the tutorial, another 2 hours is for the lectures. Okay, so before we proceed, let us study this. Let us try to remind something first. Okay, so we have a PN junction. This is a P, this is an N. So we draw it properly. This one, and then this is a P, this is an N. Then in the middle got something, middle also got something. This one close it, and then got another one. E, N. Okay, so may I know this type? What is this circuit that we call? Anyone knows? One guessing? Are you here one guessing? What is this circuit called? If we didn't connect any battery here, okay? This one is obviously PN junction, we know. Yep, this is a zero bias. On way home. What about this? This one? What about this? On way home, are you here on way home? So we know that this one is a zero bias. Then what about this? What kind of bias is this? Yep, this is the forward bias. Then what about this? Let's 用起 Yep, this is the reverse bias. So when we are talking about the forward bias and the reverse bias, okay, how does the width change? Okay, can anyone tell me? Let's say it's in the reverse bias. What will happen to the width? Transition? Okay. This one, width will increase. Why? Transition? Why do you think the width will increase? Yep. The electronic and the hole move toward the source. You're right. So it looks like something like this. All the positive charge onto here, negative charge onto here. So that's why the weight will increase. What about the other way around? Your Ming Liang, forward, forward bias. What will happen to the width? Your Ming Liang, width decrease. Why? Why do you think the width will decrease? Yep, Mr. Yong Ming Liang. Voltage stock corresponding to the built-in voltage. I won't say it's the correct one. We are saying that why the weight will decrease. I won't say it's the correct answer, even though it's a good answer. Lotonia, what do you think? Why do you think the weight will decrease? Lotonia, are you here? Yep. The more correct one is the electron move towards here, hole move towards here. So when you're increasing the electron in the hole, so all the positive charge will occupy the spaces, make the width decrease. So when you have the width decrease, remember that when we are saying the charge will flow from the high concentration to the low concentration. So here is the high concentration of the P. Here's the low concentrations of D. So that's why your P somehow will cross over at the junction here also. So in this case, this will cause the current to happen inside here. Okay, so this is the concept. So let's get back to the lecture slide. So in terms of the graph, when we are trying to draw the energy band, so for the reverse bias or the bias thing, the graph will also be slightly different. What does it mean? So let's see, for example, for the zero bias, this one is the normal graph, but normally the end will be having the lower conduction band energy and the valence band energy. EFI still remain the same. Then the difference between here and here is the VBI. This thing we learned before. But when we are trying to apply the reverse bias, since there's a reverse bias, which means that your VBI will add with the VR together. You still remember last time we played around with all the formula, which means that the gap between the EC1 and EC2 right now will increase. Then the Fermi energy level for the P region will be higher than the Fermi energy level of the N region. But let's say if we are trying to apply the forward bias VA. So right now, with the reverse bias, we know that the V total inside here in the middle is the VBI plus VR. But if let's say this one is in the forward bias, the V total will be VBI minus VA. Okay? And somehow in the graph, the electron will be flowing from the high concentration to the low concentration as I mentioned just now. Because right now, you see the difference between the EC1 and the EC2. EC for the P region and EC for the N region is getting the lesser and lesser. The reason why it's getting a lesser because VBI minus the VA. Okay? So when we are lesser, so the electron may have more chance to jump over there from the N to P. Also, this one is the high concentration of the electron, low concentration of the electron. This one is low, this one is high. So that's why it flow from high to low. Same thing happened to the hole. It flowing to here to here. Okay, hole flow here, and the electron flow here. And what interesting is the Fermi energy level will be higher than the Fermi energy level here. Okay, in this point, any question? At this point, any question? If no, then I will proceed to the next slide. So this one we know already. In the zero bias, so everything is maintained, so no electron flowing because the VBI, the potential barrier is the VBI as we know already. Potential barrier, VBI, will block the electron and the hole from flowing to each others. So this will maintain the thermal equilibrium. Okay, which means that originally in the this one zero bias, you didn't power anything, this thing will be the blocking. It acts as the block to block this from flowing each others. But when you're trying to include the reverse bias battery here, since this thing it will increase the weight. Okay, when you increase the weight, your VBI will be adding the VR also. When VBI adding the VR together, the block is getting higher. So it won't be any possible for the electron or the proton to flow over here or flow over here. It won't be happen because you are applying the reverse bias, which will add the additional voltage to block it from flowing to each others. But as we mentioned just now, when we are trying to include the reverse bias, okay, when you're trying to increase the reverse bias, and then the weight is getting smaller, your VBI will be minus VA. VA is here. Since this thing is getting smaller, your V is getting smaller also, and then all the electron and the hole will be having a chance to flow with each others. Okay, and the flow over here will cause the current. Okay. So far, any question at this point? At this, no, right? This one is quite simple and direct. Okay, so let's see. Next one. So this one is a little bit confusing, but let me explain here one by one. So you can see that here a bunch of the terminology here. But what does this things about? Okay, let me copy here to here. Okay, imagine if we have this. And then nice. We are having this one and also this one, and this one is in the middle. So this is the P and this is the N space charge region. So last time we learned that in the N region, we are doped with the ND, donor electron, donor atom. And for the P region, we dope with the acceptor atom. Okay, so last time we also deal with all these things, NO and PO. And for the P region and the N region, they also have their own NO and PO. But since these two is having N and P together, so there is something might be a little bit confusing, but actually it's very quite easy to understand. So let me explain one by one here. Okay, we start with the ND first. Since this one majority is the ND, so we assume that the majority atom, majority carrier in the N region will be the ND. Okay, N and O. Okay, N and O will be equals to the ND. But how does we see the N and O? Okay, let's see. So in the N region, majority N. In the N region, majority is N. We will denote it as a N and O. And we know that the majority will dope if the in the ND. So we equate it to the ND. At this point, can you understand? Okay, okay, oh, this part. Mm-hmm. The remaining of you? Okay. So same thing happened here. The other side. We will write it as a mana. Okay. P P O. In the P region, the majority is P. We denote it as a Na. In P region, major is P. So this thing is the same thing, just that we just repeated it for the left and the right hand. Where's my thing? Left and the right side only. Okay, then we continue here. Let's see what happened. So let me write here. This one done, 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 done. Okay, and then at this point, okay, we know the majority, but we also need to know the minority. Okay, in this part, N region, majority is a N, minority is a P and O. In the N region, minority is a P. At this point, can you understand? In the N region, minority is P and O. Okay, this one can understand. Okay, a few of you say okay. What about the rest of you? There are 28 students here, but only 5 of you reply me only. Okay, so let's continue from here. How are we going to link this P and O and N and O together? Last time we learned that Ni square will become No multiplied by Po, right? We also can apply the same thing here. Ni square will be equals to the N and O and the P and O. You see, N region, majority, minority. We can further write it down because we know that the N and O originally we donate it as a ND. So we put an ND here, P and O. So on the other hand, we also can say this thing as this. P and O will be equals to the Ni square over ND. Can you understand this? This part, okay or not okay? Okay, get back to the P side. Okay, PPO is the majority in P region. Same thing, MPO, minority in P region. Then we can also do the same thing. Ni square divided by the PPO will become the MPO. Then this thing you can rewrite it as a Na because we dope it the acceptor atom. Okay, this part okay? Everyone? So one trick for you is this P inside here is to saying that which region are you in right now. Okay. Okay, so this one done. Okay, P N O. Oops. Where? Let me see. MPO is the minority in the P region. MPO, yeah, minority. Nothing wrong. Don't worry. Okay, so right now we have the other two. We have the NA, NT, uh, NNO, PPO, PNO, and PO. So this is for the M region. This is for the P region. And then right now, we also got one thing. We call it as the NP. P stands for the P region. But what about the NP? So when you see a O here, it means that it is the thermal equilibrium. Okay, thermal equilibrium. But when you see the without O here, it will be trying to calculate that what are the total of the minority in this region. Total of the minority means that in this part, this space charge region, even though we know that this is all with the negative charge, but there might be some positive charge here inside here also. So you want to know that what are the minority from here to here, MP. So in this case, MP, it will stand for the total minority. Carrier in P region. PN, total minority carrier in N region. At this point, can you understand? Okay. Okay. So what you have to know is for this PNO and PO, it doesn't consider the small region there only. But and it's in the thermal equilibrium. But it's not in the thermal equilibrium, then you need to consider all the factors inside. So you will have the total minority. Okay, can you understand? Still can follow? Okay, three of you say yes. What about the remaining of you? Can. Okay, then proceed. We have the very last part. MP in the negative SP, PN in the SN. If you still remember last time, when we are calculating the SP and the SN, it is here and here. This we put a negative because SP is just a value. Then we put a negative to denote that it's in the other direction. So when we are trying to put the MP or maybe the PN here, this one is to tell that at this point, what are the minority or carrier at this point? Or at this point, what are the minority at this point? Okay, so this one is to denote it as the age at this point. Can you understand? Okay, so back to the slide just now. We already explained every single item over here. NA, acceptor, ND donor, NNO thermal equivalent majority, PPO thermal equivalent majority. So minority, minority. Then this one is the total minority and the total minority in the P and the N region. Everyone okay at this point? Okay or okay? Oh. If you need me to explain this again, you let me know. I can try to explain to you again. Okay, since we know every single thing over here, but how are we going to relate everything together? So let's say if you want to calculate this, or calculate this, calculate this, or calculate this, if we are just given the NA and the ND, how are we going to calculate every single item over here? So this is what we are going to learn here today. So let's get back to the Google slide. So for your information, the Ohm's law cannot be simply applied on the diode because it has its own condition. Because it does not happen in the linear way. You can see this. This was a non-linear graph actually. Okay, so there's a several concept just to for your knowledge only. So the ideal current voltage relationship is based on the four assumptions. So the array depletion, Maxwell constant, low injection, and actually this one nothing nothing much important. The important one is the boundary condition over here. Okay, because it will involve some of the calculation. Okay, so the important thing is this thing. So let me remove this. Okay, last time we learned about this, we are going to calculate the VBI equals to the VT ln NA NB over NI squared. We also know that this thing is in the KT over E. But if this thing is in the, let's say, 300K, so we know that this one will be equal to 0.0259. So ln NA ND over NI squared. And then we are trying to restructure this thing. E VBI over KT equals to ln NA ND over NI squared. Okay, so we can also rewrite this negative ln NI squared NA and D. Okay, and then NI squared NA and D will be equals to the exponential VI over KT. But in this case, it just write in this way to make it look nicer over KT. Okay, so right now, just now we have something. Okay, we have the ND lah, NA, then we have the NNO, and then we also have the PNO, NA. For the NA, we know that this one is a P, PO, and PO. Okay, so imagine that if we want to use this majority to find the minority of the opposite side, what are we going to do? I repeat again. If we want to use the majority in the N junction, in the N region to calculate the minority in the P region, what are we going to do? So here's the thing. At first, we write this formula in this way. NA and D exponential negative EVI over KT. Okay, so we are trying to relate all this thing together. ND, we know that the ND will be equals to the N and O. This thing is the majority in n region are donor. Make sense? So we can write that ni square will be equals to the na and no equals to the exponential negative pi over kt. Okay, at this point, can you understand? This part okay? Okay, very simple and easy. Okay, then we are going to tackle this PNA. We also know that the NA will become the PPO because we look if we look in the acceptor part. Ni square will become the PPO and NO exponential negative VBI over KT. And then in this case, we also can write it as Ni square divided by the NPO. Okay, I think you still remember this, right? Just now we explained this. And I square will become the PPO multiplied by the NPO, provided if both sides are also the silicon or the same thing. And then since PPO is equals to the Ni square divided by the NPO, we can write in this way. Ni square divided by the NPO. So this thing and NO we move to the other side. Exponential negative EVBI over KT. And then this thing we can remove each other's. Eventually, this will become this negative E VBI over KT. Okay, at this point, can you understand? In this case, we are using the majority in N region to find minority in P region. Okay, at this point, can you understand? This part okay? Okay, so basically it's very simple. I think it's quite direct also. Any question at this part? So let's say if the question given you, if you are given the ND, let's say it's 1 times 10 to the power 15, then you will ask to find all these things. If you are given also the VBI, let's say it's a 0.625, so you will ask to calculate everything over here. Okay, very simple and easy only. And KT over E, when you do the KT over E, actually is equal to 0.0259. If you put everything originally without changing into the EV. Okay, then we continue if there's no question. Okay, so this one I already explained just now. Is saying that if you are trying to apply the VA inside there, then the weight will become getting smaller. If you're getting smaller, the current will flow through there. Okay, explained already. But we need to know this. Okay, what happened if we are trying to apply the forward bias? Okay, what will happen? Everything. If we are trying to apply the forward bias inside here, something will change. Imagine if we are trying to apply the forward bias, we need to have one formula first. Okay, this formula, it comes from nowhere, but you just need to remember it only. VBI minus VA over KT. Okay, in this case, this NP actually is the NP in the negative SP. Just to make it simple only, so that's why I write it simply. Originally, just now we denoted this one as a total, but in this case, NP is actually equals to the NP at the negative SP there. Okay? Okay. So at this point, let's see what are we going to do with this. First, we try to split this NO, sorry, NO, SP, negative E VBI over KT, exponential E VA over KT. Okay, so there's one thing we call it as a low injection. What is the low injection? Low injection means that, okay, if you have zero injection, the majority carrier electron concentration on the N side does not change significantly in the forward bias, but the minority carrier electron on the P side will be changed. Just for example, let me draw something like this here. So let's say if you are converting to the forward bias, if you are converting to forward bias, electron will flow here, and some of them will flow here. If you assume that the electron here is 10 to the power of, let's say, 25 for the N. But for the N over in this side, N maybe is 10 to the power of 4 only. Okay? So let's see. If you are trying to increase, let's say 10,000. Okay? So for him, it didn't see any significant changes. Just for example, 100 times 1 is equals to 101, equals to more or less 100 only. Okay? It didn't change anything. But for this, if you flow something from here to here, even though if you only flow, let's say 10 to the power 4, it, for the minority, it will consider as a significant change. Okay? In this case, we call it as a low injection. Okay, for the low injection part, can you understand this? Okay, because the theory that we are going to ask later will involve a little bit of the low injection. For the rest of you, can you understand this for the low injection? Okay, then we proceed for the derivation there just now. Okay, so for the low injection, your NO will more or less equals to the NM majority, which is the ND. Didn't change much. But your MPO will not be the same as the MP, as we mentioned just now. Also, the earlier, we know that the MPO equals to the NNO exponential this thing. We denote it just now. We derived it just now, earlier. Okay. This part will become the MPO. This thing we have done. Then we can shorten it in this way. MPO exponential E VA over KT. And then this will become the NP. And this NP is the minority carrier at the edge. Okay. This MP3 is rewrite as a SPA, be more accurate. Same thing also for the P side, piano exponential EVA over KT. Okay, so this is the graph. Let's see. So these two formula are the one that we have derived just now. Okay, and this is the SP and the SN, PNO and the NO. So this is how we do it. So maybe we see one example. Imagine that if we have this example. Okay, consider a silicon at the PN junction. Assume that the ND is 10 to the power 16. That NA 6 times 10 to the power 15 CMS cube. Assume the forward bias of the voltage 0.6 V. Calculate the minority carrier concentration at the edge of the space charge in the forward bias PN junction. So in this case, just calculate the PN only. It didn't calculate the MP. So what are we going to do? So at first, we need to know that what formula that we are using. We are going to use this PNO exponential VA over KT, and also the MP equals to the MPO exponential EVA over KT. Okay, then we settle the P side first. PNO. Okay, at first we need to know what is this. Thermal equilibrium minority in N region. Okay, PNO. But what about the thermal equilibrium majority in N region? So what's this? This is the N and O. And we can also write it as a N D. Can you understand this? Okay, this thing we have learned just now. In the N region, majority is the N. And it equals to the donor atom because we do it inside the donor atom. Okay. Okay. Since we know this and D is given from the question, then we can also calculate this. Ni square divided by the ND will become the P and O. Lecture start already calculated for you. 2.25 times 10 to the power 4 cm minus cube. 2.25 times 10 to the power 4 minus cube. Okay, since we have know this already, we can just replace inside here. EKT is equals to the 0.0259 as I mentioned just now. VA 0.6 given. We just need to hunt down everything inside here to calculate our final answer. That's it. Very simple. So right now, I want you to calculate the MPO and the MP. Okay, you can try to do it now. So as we mentioned just now, the MPO multiplied by the PPO will equal Ni squared. PPO is equals to the Na. So Na is given from the question, Ni squared. So you just then calculate the MPO directly. Okay, what's the value for the MPO? Anyone? On mailing? Okay, our friend get the 37500 MPO. Do you guys get the same answer as your friend? 陈旭偏? Okay, then what are the value of the MP? So Yen Chang, are you here, So Yen Chang? Okay, what is the value for the MP? Okay, okay, So Yen Chang, after calculating, tell us the answer. Okay, our friend gets the answer already. Do you get the same answer as your friend? 4.41 times 10 to the power 14. What about the rest of you? Lao Lục Tính, get the same answer as your friend? So I believe the answer will be a little bit weird. Is it? So I don't think it's the right answer, to be frank. So let us calculate it. 37500 multiplied by the e to the power of, yep, something wrong, right? You see something wrong there. VA is 0.6 divided by 0.0259. Okay, you should get about 431. Is it? What's the answer do you guys get? From guessing? What about you? Yep, 4.31, which is my answer. Yep. All right. So I believe this is the answer. So let us calculate something. So given the silicon and A is, let's say, 2 times 10 to the power of 14, and D equals to 2 times 10 to the power of 16. Okay. Then assume at first is the zero bias. Then you calculate the. I think zero bias is a little bit simple. Okay, lah, reverse bias. So you are asked to calculate the SP, SN, W, Dmax, and also the junction capacitance. But if you somehow can reverse bias VR is 5 volt, if somehow if suddenly you change to the forward bias, if the VA is let's say VA let's say 0.5 volt. Okay, and then you are going to calculate the NPO, NNO, NP, uh, MPO, NNO, NNO. Okay, NNO is already there. Don't have to calculate. Also, maybe a calculator. NPO is there. And then you calculate the PNO and PN. Okay, calculate everything, every single thing here. Okay, start doing it now. So if you connect to the forward bias, the NA and ND still the same, just that right now change the word only. Okay. Have you calculated the first part during the reverse bias part? Anyone can tell me what's the SP value? Any volunteer this time? Wu Jianming, are you here, Mr. Lu? What is the value of the SP? Okay, 5.996 times 10 to the power of negative 4 cm. The rest of you, do you get the same answer as your friend? Any plus one? Plus one, okay. The rest? DJ Lim, do you get the same answer as your friend? Okay. So, DJ Lim, can you tell me what's for the SN? Okay, 5.996 times 10 to the power of negative 6 cm. Okay, any same answer? Any plus one? Okay. Go can sing. What are the value of W? Mr. Go can sing, are you here? Mana dia? Sudah hilang. Go can sing, are you still here? Okay, never mind. We pick the other guy. Don't waste our time here. Lim Chung Wei, what is the value for the W? Lim Chung Wei, are you here? Value of the W. Okay, 6.06 times 10 to the power of negative 4 cm. Do you guys get the same answer? So basically, you just need to add SP and SN together only. Okay, any plus one for the answer? Okay, then let's see the Emax. Ng Han Xiang, what is the value for the Emax? Ng Han Xiang? Okay, 18501.055. Do you guys get the same answer? Okay, and then the junction capacitance. Let me fix. Brenda, what are the junction capacitance? What value do you get for the junction capacitance? Okay, 1.7097 times 10 to the power of negative 9 para per cm square. Okay, do you guys get the same answer as a Brenda? Okay, very good. So basically, this is the way that we calculate everything. Formula is already given. You can just simply go to search it out and then try to find everything. Then we go to the second part. Have you done the second part? If you have done the second part, try to say yes. If you are still calculating, then you type no. Have you done the second part for the forward bias? Yes or no? Okay. Try to do the forward bias part. Then should be easy. Since this one is in the forward bias, then you need to use the way that we have calculated just now, which is this one. Okay. Okay. By the way, this one the as NP is on the junction side. Junction side. Okay, so let's resume back to our last part. So, Low Tune, since you say you have done it, so can you tell me what are the NPO and also the NPSP? Okay, we know the NPO. This one is the minority in the P region. We use the Ni square to divide the minority in the P region. So we divided by the PPO, which is really equals to the Na. So Low Tune, what's the answer for the NPO? Okay, good. 1.125 times 10 to the power of 6. Then this thing, we just need to use the relevant formula, 2.724 times 10 to the power 14. CMS cube, CMS cube. Does everyone get the same answer as your friend? MPO and MPSP. Any plus one? Okay. Okay, then let's go to the last part. Yo Dong Ho, what about the PNO and PNSN? Yo Dong Ho, are you here, Yo Dong Ho? Okay. PNO first. Okay, you say a PNSN is equals to, sorry, positive 2.724 times 10 to the power 12. What are the PNO? Yep, 1.123 times 10 to the power 4. Okay, any plus one for this? Okay, so basically, this one very simple. I believe most of you can do it. So as I mentioned earlier, today we end the class slightly earlier. Okay, so we will stop here for today. So if no question, I will end the class for today. Thank you very much for the attention and have a nice day. Goodbye everyone. I will see you by the upcoming tutorial class. Bye everyone.